Supposing we're given this problem. Take 2/3 and divide it by 5/7. In a case like this, we're usually told, let's use the rule keep, change, flip, which means you keep the first fraction, 2/3, you change from division to multiplication, and you flip the second fraction. So 5/7 becomes 7/5. And when we multiply across, 2 times 7 is 14, and 3 times 5 is 15, and that is the right answer. Now, although most people know how to use the keep, change, flip rule, if you try and find out why it works, you may find that it's a harder question to answer than you originally supposed. In fact, some teachers say, ours is not to question why. Flip it round and multiply. Well, that's a good way of remembering it, but it's not very satisfactory as a response. So let's try rewriting the problem in a slightly different form. Let's say we have 2/3 over 5/7. Now this is exactly the same problem. 2/3 over 5/7 is the same as 2/3 divided by 5/7. But when we write it out in this form, we can understand it not as a division problem, but as a matter of simplifying a complex fraction. And to simplify it, if we could get rid of what's here in the basement, if we could just clear out the basement here, which we could if we could turn that into a 1, then we'd have a much simpler situation. We'd only have the numerator to deal with. To turn that 5/7 into a 1, let's multiply it by 7/5. And we're going to see in a moment why multiplying it by 7/5 turns this into a 1. But for the moment, let's go up to the numerator and see what we need to do to justify this proceeding. We can multiply the denominator by 7/5 if we multiply the numerator by 7/5 as well. Because anything divided by itself is equal to 1. 2/2 equals 1. 3/3 equals 1. And 7/5 is also equal to 1. So when we multiply this whole business here by 7/5 over 7/5, we're just multiplying it by something which equals 1. So we're not changing the meaning at all. We are, however, changing the form rather dramatically, as you shall see. So when we multiply this all by the new fraction equal to 1, well, let's see what we get. Multiplying across, 2 times 7 is 2 times 7, and 3 times 5 is 3 times 5. So much for the numerator. And the denominator, we've got 5 times 7 over 7 times 5. And now we see why we chose 7/5, which is the reciprocal, that is to say, the flipped around version of 5/7. When we multiply them, we see, okay, the 2 7s cancel out and the 2 5s cancel out. So we've got nothing but 1 in the denominator, and what we have in the numerator, 2 times 7 over 3 times 5, well, that's exactly what we had back here when we kept, changed, and flipped. So we can see now that keep, change, flip is just a shorthand version of this whole process, whereby we rewrite the division problem as a complex fraction. We multiply the numerator and the denominator by the reciprocal of the denominator, and everything in the denominator resolves into a 1. So basically, we perform this whole elaborate central operation here in our heads, or perhaps not even in our heads, without even thinking about it. We simply streamlined that away and only kept the part that really made a very visible difference. The part where we multiplied the numerator by the inverse of the denominator, the whole denominator having canceled out. So keep, change, flip is just a shorthand version of rewriting our problem as a fraction, as a complex fraction, and then simplifying it. We just saw that when you're asked to divide a fraction by a fraction, for example, 2/3 divided by 5/7, the keep, change, flip, the 2/3 now times 7/5 is really shorthand for writing our original problem out as a complex fraction, 2/3 divided by 5/7, and multiplying that all by the reciprocal of the denominator over the reciprocal of the denominator. And in the denominator, everything cancels out and turns into a 1. And so keep, change, flip is really a shorthand version of really a simplification of a complex fraction, representing our problem as a complex fraction and simplifying it. But keep, change, flip just cuts to the chase and gives you the part which will give you the answer without going through all the steps necessary. Now, although when you first see keep, change, flip, it looks like a conjurer's trick, and most math teachers have a hard time explaining when they're asked why it works. Now we see that that wasn't really the difficult thing. What really is a bit of a challenge to explain is why this part, the multiplying a fraction by a fraction, works. Why when we say 2/3 times 7/5, it actually equals 14/15. So let's look at this business of multiply the numerator and the denominator straight across. When we say 2/3 times 7/5, we could write that out again as 2/3 times 7 times 1/5. It's exactly the same thing that we have here now, but I've written it out in a longer form so you can really see every step of the process. First of all, we're going to multiply 2/3 by 7. That's 7 times as many, so 7 2/3 is 14/3, so to speak. So this is going to then be equal to 14/3 times 1/5. Now, the multiplying of the numerators, just making 2/3 7 times as big, is pretty easy to understand. What's a bit hard to grasp is how the bottom part works, how when we multiply the thirds by the fifths, we get 15ths. Why should that work? What does it really mean to divide a divisor? Well, let's start off with what 14/3 really is. When we say we've got 14/3, we're really saying how many boxes, let's say, divided into thirds can we fill with 14? So if we were to start off here, we've got 1, 2, 3. Well, 1 is taken care of. And then we've got 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. We've been able to fill 1, 2, 3, 4, and 2/3 boxes divided into thirds with our 14. And if we did that as a long division problem, if we said 3 into 14, we'd say, all right, 3 goes into 14. Well, 3 times 4 is 12. 14 minus 12 will give us a 2. 3 doesn't go into 2, so it's 4 and 2/3. And we see 1, 2, 3, 4, and 2/3. So 14/3 is really a way of saying, all right, how many boxes divided into 3 can we fill with 14? How many 1/3s have we got when we've got 14 to play with? Now, when we've got 14/3 times 1/5, fifth, what we're saying is, all right, we're going to take our 14 distributed amongst boxes divided into 1/3 size sections, and we're going to take each of those 1/3s and subdivide them 5 times. So first we subdivide them. Each 1/3 has been divided into 2, 1, 2, 1, 2, 1, 2. Now each one has been divided into 1, 2, 3, 4, and 5. So we've got 1, 2, 3, 4, 5 subdivisions of the original 1, 2, 3 subdivisions. And what we were told to do when we were told to multiply 14/3 by 1/5 is, okay, we've got our 14 to divide amongst 1/3 size sections, and it'll take 3 of these sections to equal 1. And we're going to subdivide those dividers, those triple dividers, 5 times. And then we are now asked to see, all right, how many ones, how many full boxes can we get if we try and distribute our 14 items in a box divided into 15 subsections? And this is what 14/15 really looks like.